Hello, this is Rick White, and here is another podcast on mathematical induction. If we start with our left-hand side, we need to show that it holds true, the statement holds true for n equals 1. So our left-hand side says 3 times 1 plus 1 plus 4, times 1 plus 4 is 3 plus 5, 3 times 5, which is 15. And then our right-hand side says 1 times 2 times 15 all over 2, which of course that also equals 15. And now we are ready to go. So the next step, assume true for n equals k. So we have a statement that says 3 times 5 plus 6 times 6 plus 9 times 7 plus terms of that same, with those same characteristics. So we have 3k times k plus 4. That we're assuming is k plus 1, 2k plus 13, and all divide 2. Okay, and step number 3, as you should know by now, is show that if it is true, then show that it's also true for the next case, the k plus 1. Show true for n equals k plus 1. N equals, not less than, okay, k plus 1. So we should have something that looks like this. 3 times 5 plus 6 times 6 plus all these terms, 3k times k plus 4, and tack on the next term, which is 3k plus 1. So if I distribute that, I should get 3k plus 3 and then k plus 5. And that should be k plus 1, k plus 2, 2k plus 15. If I stick in a k plus 1 there and distribute, 2k plus 15 all over 2. Good. Okay. So I'm actually going to go back one step. I didn't like doing this. Sometimes you just have to think about these things twice. So I'm going to keep this as 3k plus 1. All right. I'll show you why I did that in a second. Just thinking about it twice. Okay, so clean it up a little bit. It's hard to write with these things. So now we have our substitution piece. Remember, this is our substitution piece right here. And we have our goal right here. Okay. So our substitution says this whole piece out to right here should be k plus 1, 2k plus 13, all over 2. And then if we have this one other piece here, we have 3k plus 1, k plus 5, k plus 5. Good. Okay. The next step is always the same when it comes to these types of induction problems. Just common denominator and put the two pieces together. So we have k plus 1, 2k plus 13, plus 6k plus 1 and k plus 5. Whole thing divided by 2. All right, so if you can see from before, I distributed that 3 right there, and the reason I pulled it back out is because I still have a k plus 1, and this over here has a k plus 1. So I'm going to actually factor out that k plus 1, and it would have been a little bit more difficult to see if I had the 3 in there. So I'm going to go up here, I'm going to factor out that k plus 1. So k plus 1, and we have a k, we have a 2k plus 13, we have a 6, I'll just distribute that 6, we have a 6k and 30, like that. I think that looks okay. And if we distribute that k to that piece inside the square bracket, we have 2k squared plus 13k plus 6k, so that's 19k, plus 30. All divide 2, sorry. All divide 2, and all divide 2. And then the last piece here, if I factor this, I get k plus 1, 2k plus 15, and a k plus 2. Everything divide 2. And you can see that is the exact same thing right here. And make sure you finish with a statement summarizing your steps of mathematical induction. There you go.